Hello, everybody. Welcome to lesson one of geometry. First basic introductory lesson, just covering some definitions and some non-definitions, really, actually. And let's jump right in. Geometry, the word comes from some ancient Greek words that mean earth measurement. And the idea is that the ancient Greeks looked at what the Egyptians did, because every year in Egypt, the Nile would come and flood everything and wash everything away, and then they would have to measure out the land again. And so geo, like geocentric, means earth, and metry just means measurement. So earth measurement. This is how we measure space. This is how we create figures in space for measuring different things. A definition, the way definitions work in modern math in particular, right, is that we have a bunch of words that we use to describe something, to define it, kind of create a boundary around it to explain what something is and make it clear. The thing is, uh, when we get to something, to some basic word that then we can't use any more basic words to describe, then we've reached what we call an undefined term. And in geometry, we have a few undefined terms. So the words point, line, and plane are undefined. Now, when Euclid first wrote his geometry, the original geometry textbook, he did define point, line, and plane. So we're taking the more kind of modern geometric approach, the more modern mathematical approach, and saying that these are technically undefined terms. We can describe these, we can conceptualize them and think about them and use them in a technical way, but in a technical way, they can't be defined. All right, so what is a point? Well, the way that we can describe a point is simply as a location, as a particular place. Okay, and there's no length. A point has no length or width or any measurement in any direction. It's just one single point, right? No width, etc. A line is a set of points along a straight path. And then, if you think about it, well, what do we mean by location? Well, we would say a point. And then we end up using the same word to try to define the words that we have in the definition, right? A set of lines along a straight path. Well, what does straight mean? Linear. Then we're using line again, right? So again, technically these are not definitions, but they are descriptions. In geometry also, it's really important, and in math in general, that we have very kind of clear and agreed upon ways of defining things and of describing things as well. And so we represent a point with a dot, just like I have here, right? I've got 4 points represented, and I've represented them with a dot. That's how we represent a point. And the way that we name points is with capital letters. So this is point P, point Q, point S, and point R. Capital letters name points. The way that I represent a line is with just a straight line, the way I would draw it. And I put arrows on the end because lines go on forever. And then you could be thinking, what if like it stops? Well, that's called a line segment, or if it's on one side and it goes on forever on the other, that's called a ray. We'll get to that later. For now, a line goes on infinitely in both directions. So we put arrows on both ends, and we have that line. The way that we name a line is with either one lowercase letter or by 2 points on the line. So this is line Z, or we could name it as line PQ. And then if I label it, if I name it using the points, I have to draw the line above it. And I draw the line with both arrows, so I know that I'm talking about the line that goes on forever in both directions. You could also call it line PS or QS as well. It means the same thing. Okay, collinear. This word collinear means on the same line. Look, it's got like so co meaning together, and an extra L in there, and it has the word line in it. Collinear. We pronounce it collinear. And we can have three or more points. It's a set of three or more points that are on the same line. So here we would say that P, Q, and S are collinear. Notice that you need more than 2 points in order to call them collinear, because you could have any 2 points. Between any 2 points, you can draw a line, right? You guess, well, are P and R collinear? Well, yes, there's a line that goes through both of those. Um, and so, it doesn't really mean much to say that 2 points are collinear, but three or more points, you say collinear means they're all on the same line. If they are not on the same line, if there's not a single line that you can draw through all 3 points, then we say they are non-collinear. Non, right? So not on the same line. And in this case, again, you need three or more points in order to have non-collinear points. So that would be like P, Q, and R are non-collinear. P, Q, and R are not all on the same line. Very simple, right? Just uh, some of these concepts. Now, a plane. This is the third indefinable term. And we can think of it as a surface that goes on in all directions infinitely. Surface in all directions. Okay, flat surface that goes on infinitely. And the way that we represent a plane, okay, so the way that we represent a plane is just with a quadrilateral of some kind like this. And again, it's implied planes go on infinitely in all the directions of the plane in that flat plane, but we draw that boundary there just to indicate this is where the plane is. Okay, the way that we name a plane is either a couple of ways, either uh, with a capital letter. It's actually cursive. Like when we have these cursive kind of fancy letters, that's the name of a plane, kind of cursive capital letters. Or you can name a plane using 3 points. Remember, you need three or more non-collinear points in order to define a plane. Because if they're all in the same line, then you can have a plane that is like kind of turning, right? And so you need three non-collinear points to name a plane. And so this could be either plane H. How am I drawing this H? Like this, fancy H, or plane. You have to write the word E, D, F, something like that. And then coplanar or non-coplanar. So just as points can be linear or non-collinear, so lines can also be planar or non-coplanar. The way that we draw lines, right? If I draw lines like this, that's just all solid like this, and it's hard. We're trying to represent 3 dimensions and 2 dimensions on the paper here. This indicates that these lines are in the plane. Okay, they're kind of like lying on the surface of the plane. This line M, though, you can see there's a point where it kind of hits the plane, and then there's this dotted part. The dotted part means we can't see it. It's kind of like behind and underneath the plane, and then it pops out again underneath, right? So this line M intersects this plane at point N. Okay, and we would say that so lines P and Q are coplanar, but line M and P are non-coplanar. Also, uh, line M and Q are non-coplanar to each other. Just means they are not in the same plane. And then I said the word intersect, right? The idea of intersection. So an intersection is a set of shared points between two figures. So in this diagram, we have plane E and line K. So plane E and line K intersect at point H. So H is the only shared point between plane E and line K. Okay, but if I have two planes that intersect, right, two planes intersect in a line. So plane K and plane J intersect at line M. All of line M represents all of the points that planes K and J share. Okay, so when a line and a plane intersect, they intersect at a point. Two lines would intersect also at a single point. And when two planes intersect, they intersect at a line. So here are some kind of practice problems. I've got this diagram, and we're going to go through these together. So let's take a look at this first and try to make some sense out of the diagram. It's always good to look at this, kind of get your mind around it first, and then start to answer the question. So I've got two planes intersecting here, J and G, and there's this line A that's kind of going through, right? It's behind, so it hits plane J here, hits plane G here at H, goes all the way through. Line B, also line FD, is the place where these two planes intersect. I have a point I. It's just the way it's drawn by convention looks like it's in plane G. And then line C uh, is also in plane G, and it looks like it hits line A at point H. Okay, so name two collinear points. One possible answer for this would be F and D. Right, here's point F, here's point D, and they are both on the same line. In reality, you could name any 2 points for this because any 2 points are on the same line. Okay, what is the intersection of planes G and J? Okay, well, that's this. I identified this earlier as line B, so I can say B, or I can say line FD. It says, what is the intersection of plane J and line A? So here's plane J, here's line A, point E. So that's the answer there. What is another name for plane G? Remember, named planes can also be named by the 3 points, right? So plane, I just have to pick 3 points that are in this plane, and I've actually got four, D, F, I, and H. So we can just call this um, DFH. Okay, so plane D, FDH. I said DFH, and I started writing F first, but it doesn't matter. The order doesn't matter. And then it says, what is the intersection of lines A and C? Point H. What is another name for line B? That would be line FD. And when I name it this way, I have to put this line above those 2 points. And then it says name two coplanar lines. So two lines that are in the same plane. Well, I've only got three lines mapped out here, line A and then lines C and B. Lines C and B are both in plane G. Okay, so two coplanar lines, C and B. Okay, so that's it. This is your uh, lesson one on geometry: points, lines, planes, coplanar, non-coplanar, collinear, non-collinear, and intersections. So thanks for watching. Don't forget to like and subscribe, and stick around for lesson two.